Welcome to my talk, Scalable Asset Pipelines for 3D Commerce at AWE HR 2021. My name is Limper and I'm Chief Technical Officer at DGG. Quick introduction. We at DGG create a software called Rapid Compact, which lets you automatically optimize your 3D content for different kinds of real-time use cases such as AR, VR and 3D on the web. We are also providing services around creating scalable automated 3D pipelines, which will also be the topic of this talk. I originally have a tech background in 3D graphics. I did my PhD on how to automate the optimization of content for the web and for AR. And I also worked at Fraunhofer, which is a research institution that is mostly known for the creation of MP3, the audio standard, but we also contributed a lot to 3D standards such as X3D and GLTF. And that's going to be another focus of this talk. GLTF being a standard format for publishing 3D content on the web and in other real-time use cases. And I'm involved with the Kronos group, which is the consortium that maintains this standard. And there I am active as the co-chair of the 3D Commerce Asset Creation TSG. So let's look at what 3D commerce actually means today, and specifically, since we're at AWE, where can we find AR in e-commerce today? So here are some example applications. You can see on the left-hand side and in the middle applications by Otto Group and by IKEA, where you can place furniture virtually inside your home. So these applications help you to locate a 3D model, a virtual model, inside your physical space using your smartphone, and you will easily see how the dimensions are and if it fits into your space color-wise, but especially regarding the spatial the dimensions, the spatial aspect. So this is highly useful because retailers can save money that they would otherwise spend on returns. So if you buy some piece and you figure out it doesn't fit, you can return it, and this causes costs for the retailer. It also causes stress for you, and this is all made much less likely if you have an AR app to check if something fits into your space ahead of time. And not only big corporations are doing this, but many thousands of merchants on Shopify, using the Shopify platform for their stores, can already use 3D technology using the Shopify platform. And on the right hand side, you can see an example from Shopify showing two baby strollers, and actually only one of them is a real one. The other one is a 3D model that has been put into the picture with augmented reality in real time inside an app. So now it's your turn. You can make a guess which of these two strollers is the real one, which one is the virtual one, which one is just a 3D model. So the solution is the real one is on the right hand side, the one on the left hand side is a 3D model. It's very, very hard to see actually, and you can get it a bit from the shadow maybe, but in general the quality is already so good that it looks really believable, especially regarding the dimensions and the perspective, right? So we could now stop and say, okay, the problem is solved. We have AR in e-commerce, that's great. Why do we need to talk about how to create a pipeline for that? It apparently already works. Well, it's not so easy. So there's actually a big challenge left, and that challenge is related to the content. So I call it the offline real-time content gap. And you can see here on the left-hand side some CGI renderings from the IKEA catalog and picture, and then you can guess actually that parts of these are generated with the help of CGI, right? Like not all of this are like photographs. Actually, most of the content in the IKEA catalog is CGI and no photograph. So these models are already there. We already have 3D models. Why don't we just take those and put them into augmented reality apps? Well, it turns out that this is not so easy. The offline CGI content is meant to render photorealistic images within, let's say, a couple of minutes, right? It takes a couple of minutes and you get a photorealistic picture. You can put that somewhere, done. That's great. In real time, it's a whole different story. You have a 3D model in a very specific format that runs inside a real-time 3D graphics engine, and you want to generate one picture within a couple of milliseconds, right, at interactive rates. So that's like very different requirement. And on the other hand, you need very compact files because they should be streamed over the web, right? So you want to go to an online shop, browse, press, see this in 3D, and then you want to instantly see it. You don't want to wait for like 100 megabytes to be downloaded or so. It should be rather in the 1-digit megabyte range, like 1 or 3 megabytes or something like that. And the last aspect that's really crucial here is materials. So the real-time rendering systems use usually quite different material models compared to the offline CGI rendering systems. So there's a big gap, and the challenge is obviously now having millions of assets already that are ready to be rendered for like offline CGI use cases. How can we get those millions of assets in a form where we can use them in real time? So this is not an easy question, and because of that, many players in the field, like retailers, but also tech companies like us, we have come together and formed the Kronos 3D Commerce Working Group. And the industry consortium Kronos helps to bring all of these companies together to work on exactly that problem. How can we deploy 3D content in e-commerce at scale? And more specifically, there's one group that I would like to talk about and like dive a bit deeper here, which is the 3D Commerce Asset Creation TSG, which is all about establishing workflows and guidelines for the creation of 3D assets for e-commerce. You can get involved yourself, even without being a member. Just have a look at the GitHub pages or the Kronos pages, and specifically here there's the kronos.org/3dcommerce page where you can figure out more about the whole 3D Commerce Working Group. So I will now show you parts of a workflow on how to create 3D models for e-commerce. And here's the example. So we'll usually, in all the workflows, start by creating geometry, like a mesh. And there are different methods to do this. You can have a 3D scan, you can have a CAD model, or you can use classical 3D modeling, for example, by looking at a reference picture. You will then perform some cleanups, some optimizations of the geometry and topology. Then you will perform unwrapping to get a 2D representation of the 3D surface, which can then be used to assign textures and store information in textures, and then finally tweak the material parameters until it looks photorealistic, and then you have a high quality base asset. So these high quality base assets will be created for all your content, and then out of those, in the last step here, we will create optimized versions for all the different publishing platforms. So for different kinds of bandwidth, different kinds of client devices, there will be optimized versions. For example, one optimized version for certain Android phones with a certain mobile bandwidth, and another one for desktop PCs with another kind of bandwidth. So as you can imagine, this needs to be automatic in order to work well and not cause too much work. The artist should focus on the first parts, which are creating a high quality base asset. And again, there can be different sources for 3D content that we need for like to serve these many targets in the end. And these three sources are again like 3D scanning, CAD, and 3D modeling. And for all of these, this optimization looks a bit different actually. So nevertheless, we can create recipes for all these kinds of workflows. So for example, one recipe to create an optimized version of a CAD model, and one recipe that's different to create optimized versions out of a 3D scan, right? And having these recipes at hand, we can actually automate the creation of these publishing targets without the user even realizing it, or without the 3D artist having to care about it. And that's what we sometimes call the YouTube approach, because you know it from the domain of videos, like when you upload a video to YouTube, YouTube will automatically optimize it in the background, and you don't have to care about it. Your end users, if they are having a really bad connection on their mobile device, they will probably not see the HD version, but they will see a video that is optimized for fast download and streaming and plays fluently still. And maybe the quality will be a bit less, but it will work, right? And that's what users expect nowadays. Things should just work this way. They don't have to worry about like how large the video is, or they usually don't have to pick it themselves, right? What they want to see. Now, it should be exactly the same for 3D content as a new type of media. So automating these optimization tasks is the first secret ingredient to scaling up 3D workflows. And there's another one, which is about standards. And I have mentioned GLTF. So here you can actually see that 3D model here on the slides in PowerPoint. That is a GLTF model. And using the standard, we can serve all different kinds of platforms, including PowerPoint, but also web browsers and augmented reality apps and so on. So GLTF and related standards such as like USDZ if you want to serve iOS devices, these are very important, as well as the use of standard web service infrastructures which are built like from the very beginning to be scalable. And this allows you to also perform easily upstream modifications without having to change all the optimized versions in the end manually, but you just press a button, say, okay, update the publishing targets, and then this will happen automatically. So we have done this for all kinds of source models, including 3D scans, CAD models, and content from classical 3D modeling. And you can find some case studies on the web. If you like, check them out. And we think that there are still two key challenges left right now if we want to achieve scalable workflows in e-commerce, and one of them is the optimization with at least artist quality. So sometimes it's not that easy. Like if you want to create automatically a version like the one you can see on the right-hand side, where the wicker structure of the model is not modeled with geometry, but actually with a texture that has an alpha cutout pattern, then it's kind of hard to create these things automatically from high-resolution input. But we believe that specialized recipes and AI components will actually help with that. And another challenge is the scalable creation of these source files, like the high-resolution files themselves. And this should be more promising with the advent of 3D scanners for e-commerce, such as the BotScan Momentum, which is specialized to create like high-quality content specifically for e-commerce, for example. And naturally, there are other examples too. So the takeaways of the talk are basically that, as we have seen from examples such as the Shopify demo here, 3D commerce is already there today. It works. We can have augmented reality shopping apps that provide a large benefit. However, all these kinds of 3D models need to come from somewhere. There are different kinds of sources, and making 3D content real-time ready is a challenging task. And within this challenging task, there are two key aspects. One is automating 3D data optimization, and the other one is relying on 3D standards. So with that, I would like to conclude my talk. Thanks for your attention. If you want to get in touch, here are my contact details. You can also find me on Twitter. And if you'd like to try out our optimization solution yourself, you can also use a free plan that we have available at rapidcompact.com. So feel free to give it a try. And with that, I would like to thank you for your attention and wish you a great time at AWE Asia 2021. Thanks a lot.